All right, so the next guy we're going to talk about today is identify the quadrants for theta, given that sine theta is greater than 0 and tan theta is less than 0. So sine greater than 0, that just means that this is going to be positive. Okay, tan less than 0, that means that that's going to be negative. And sine, remember, is OH, and tan is O. So we're looking for positive sine OH values, negative tangent OA values, okay? And we want to know what quadrants we're in. So let's get a little review on quadrants. Quad 1 is up here, goes counterclockwise. Quadrant 2, quadrant 3, quadrant 4. There's a shortcut to knowing which one has positive trig functions in it. And the saying is all students take calculus, okay? So we start with, we're going to put an A in quadrant 1. We're going to put an S in quadrant 2. We're going to put a T in quadrant 3. And we're going to put a C in quadrant 4. All students take calc. Well, that's great. What does that even mean? This one means that all the trig ratios, sine, cosine, tangent, the reciprocal identities, all of them are going to be positive in quadrant 1. Only sine, and then its reciprocal, which is cosecant, is going to be positive in quadrant 2. Only, you guessed it, tan is positive in quadrant 3. And what could this C stand for but cosine? So let's just look at the sine value really quick. So we know sine is OH. Excuse me. So if we had a little triangle in here, right, we would have opposite, hypotenuse, and adjacent, right? Thinking about the normal XY quadrant system, X is negative over here, Y is positive up here, and then the hypotenuse is never negative. So it makes sense that only the sine is going to be positive in this quadrant because cosine has an A and tangent has an A. So negative A is going to be affecting the triangle in this quadrant. So only ratio that works is sine. Sine will stay positive. Okay? So now that we know all of that fun stuff, let's look at this. So we want to figure out, so I'm going to switch, sorry. We're going to figure out which quadrants, Q1, Q2, Q3, Q4, okay? And we're going to say all students take calc. Okay, this we talked about is a positive. So where is sine positive? Well, sine is positive in quadrant 1 because all of them are positive in quadrant 1. And S is for sine, so quadrant 2. That's just for the sine, okay? Now let's look at tan. Tan is less than 0, so this means negative. Well, if it's not positive, it's got to be negative. So let's look at this as if we're talking about positives here. So we know tangent will be positive in quadrant 1, and tangent will be positive in quadrant 3, okay? If it's not positive, what is it? It's negative. So then that means if we had quadrant 1, 2, and 3, it can't be 1, it can't be 3. That means it's going to be negative in quadrant 2 and quadrant 4. Those are the only options, is positive and negative. There's no in between. So if it's not positive, it's going to be negative. Okay, so let's look at the quadrants we have. We have quadrant 1, 2, 2, and 4. We want to identify the quadrants given that theta satisfies these two conditions. It has to be the same condition. So the only quadrant that satisfies both of those at the same time is quadrant 2. So your answer here is quadrant 2. Okay. Sometimes there's more than one. Sometimes there's only one. Sometimes there's 3. I'm trying to think if there's a case where there's 4. I don't believe there's a case where there's 4. So you could have one answer or more than one. All right, let's look at the next one. Sine and cosine. We need to define sine and cosine given that tan is 4/3 and theta is in quadrant 3. So let's go ahead and draw our little quadrant system again. Remember, we got quad 1, quad 2, quad 3, quad 4. You don't have to write the quadrants out every time. I'm just doing it since it's probably Been a while since you've looked at quadrants. All right, remember it has to be one of our bow tie triangles, or bow tie. So in quadrant 3, it's got to look like this, never off the y-axis. We want to find sine and cosine given that tangent is 4/3. Well, tangent is opposite over adjacent. So remember, theta is always in the origin, coming off the origin of some sort. So our opposite is going to be 4, and our adjacent is going to be 3. But this is negative x land, and this is negative y land. So these are both negative. But our ratio is a positive 4/3, which is okay because we have negative over negative. That makes it positive. Do we know what our hypotenuse is? Sure. It's a 3, 4, 5 triangle. If you're not comfortable with Pythagorean triples or a 3, 4, 5 yet, do Pythagorean theorem. So we would do -3, parentheses around that because it's a negative. Square those guys. 9 and 16, 25. Square root, we get c is 5. Okay, and hypotenuse can never be negative. So it's positive 5. So now that we have all of that, let's go ahead and find our cosine and sine. So cosine, remember, is A, H. Sine is O, H. So this is our theta. We know this is our hypotenuse. Then this is our adjacent. This is our opposite. So easy peasy. We're just going to look at our triangle for the, oops, I wrote this backwards, but that's okay. OH, so our opposite is negative, and our H is 5. Adjacent is cosine is adjacent over hypotenuse, so adjacent is -3 over 5. And that is it, my friends.